Okay, so let's solve the combustion analysis. This is an optional problem. It's a little complicated problem, so we need to read the problem carefully and then understand what kind of information has been given. So the problem says the certain mass of organic compound. So organic compound, the mass is given, and the information says carbon and hydrogen and oxygens are part of the organic compounds. So organic compounds are made out of carbon, hydrogen, and oxygen. Okay, and they are burned in an oxygen. That means, so I'm starting to think about now. Okay, so organic, which is made out of carbon, hydrogen, and oxygen, will react with an oxygen. Okay, and then they will produce carbon dioxide and hydrogen. So this is a reaction that you can imagine. And what was given here is a mass of carbon dioxide and H2O, waters are formed as a product. And the question is asking us that what is the empirical formula for the compound? So organic compound made out of carbon and hydrogen and oxygen, they write this equation like this, and then they typically write down, let's say, X, Y, Z as a number, how many carbon and how many hydrogen and how many oxygens are made out of, make up the organic compound, and they want to know what is this empirical formula, which is shown up in a box shown up here. So let's try to figure that out. So what kind of information do I want to, what kind of clue do I have here? And let's try to figure this one out. Okay, so the first information is, let's think about, okay, grams of CO2 is given. And from this, I think that I can calculate grams of carbon. Grams of H2O, here I can calculate grams of hydrogen. What about the grams of oxygen? That is actually can be combined from grams of CO2 and grams of H2O. Will give it to that. So this information is not so useful, but in return, what I can figure that out is, okay, this will be grams of organic, which is I know, minus grams of carbon, grams of hydrogen. The reason is because by the definition here, let me show you the color. So what I call the grams of organic, which is shown up here, 0.684 gram, that's for sure. And it's mentioned that it's composed of carbon, composed of hydrogen, and composes oxygen and nothing else. So from here, I have one definition that organic compound made of 3 kinds of atom and total masses can be shown up here. And so once I figure this conversion from CO2 mass to the hydrogen, to the carbon, and H2O mass to hydrogen mass, and then all I can do is figure this one out to the mass of the oxygen from the total mass of organic minus carbon mass and hydrogen mass. So let's kind of tighten it up here. So those are the 3 key information, and then what you find out from here now, if I highlight it, you know this ratio, right? So you know mass ratio. So for example, mass ratio, carbon ratio, hydrogen ratio, oxygen ratio, right? This is a mass ratio. And then what you got to do is moles of carbon, moles of hydrogen, moles of oxygen. That's a mole ratio. And you need to find the closest integer to figure this one out. And if this mole ratio is x, y, and z, and your empirical formula is carbon is there x number of carbon, y there is a H, there is a Y number of H's, and oxygen there is a Z number of H's, and that will be what we call the empirical formula. So this is our guiding map here. Say, okay, I need to focus myself the quantity that the mass ratio, and all I gotta do is convert that into mole ratio to finally calculate the quantity that I want to show up here. Okay, so how do I calculate the first one? Okay, so let's start the first one. Okay, grams of carbon. Do you remember the grams of carbon? This is what you want, and what you have is grams of CO2, right? And then multiply. You're going to say grams of CO2, moles of CO2, and then if you look at that, moles of CO2, moles of carbon, and moles of carbon, and grams of carbon. And so all you gotta do is plug in the numbers based on the information. So what's my grams of CO2? I can find the number here. That's 1.312 gram. And how many grams of CO2 is 44 gram is 1 mole of CO2, and 1 mole of CO2 was produced from 1 mole of carbon. It's a 1-to-1 correspondence, and 1 mole of carbon will weigh 12. Okay, so by doing so, what I have is 0.358 grams of carbon. Okay, so I got this first information right here. Right? So the carbon mass. So the second information, which is grams of hydrogen, it's the same drill. So you start with hydrogen, H2O, and multiply by grams of H2O, is to the moles of H2O, and then moles of H2O, moles of hydrogen atom, right? And moles of hydrogen, grams of hydrogen. Okay, what we are interested in essentially the atomic mass only here. Okay, so how much is hydrogen do we have? That's 0.805 grams. So order, let's do the blue. So 0.805, and water is an 18, right? 18 gram. 1 mole of water is an 18 grams, and then this is a 1 mole of H2O must have come from 2 moles of atoms of hydrogen. Okay, so that's a 2-to-1 ratio, and then this is a 1 mole, and how many gram? 1 gram. Okay, so by doing so, you will get this 0.090 grams of hydrogen. Okay, so then what do I do? Number 3, grams of oxygen, right? This is essentially this set of what I want to know, the mass ratio. And then this one, I just don't need to do the hard way. It's just subtraction of organics minus carbon minus hydrogen. Because oxygen organics are, when they react with air oxygens, they become CO2 and H2O. So we cannot have a one-to-one correspondence such as being used in moles of carbons to moles of CO2 or moles of hydrogen and moles of H2O. Right? So we can just conservation of mass idea can be calculated here. And then by doing so, the total mass was, what was the total mass? That's shown up there. Wait, 0.684, right? So this is our total organic mass. This we talked about here, and minus 0.358 minus 0.090, and that will lead you to 0.236 grams of oxygen. Okay, so I have get to a very important clue. Those are the mass ratio of this compound. And the next step is okay, I got my mass, so my conversion to mole ratio, so that's a mass ratio, and I need to convert it to mole ratio. So moles of carbon is grams of carbon multiply grams of carbon mole of carbon, right? And so this will give me 0.358 multiply 1 mole is 12 gram, right? So 1/12, and that is something like 2.98 10 to the minus 2 mole of carbon. Okay, that is first. Number 2, moles of carbon. That's grams of hydrogen. Grams of hydrogen, moles of hydrogen, and 1 mole is 1 gram, so pretty much the same deal. 0.90 1/1, and that's, so therefore that's a 9.00 10 to the minus 2 mole carbon. Okay, not mole per mole hydrogen here. And third one is mole. I'm sorry, I made a mistake here. Mole hydrogen and mole oxygen is grams of oxygen, and 1 mole of oxygen, that's a 16 gram of oxygen. Okay, so by doing so, this is all gone, right? So this is the idea that you learned from the unit conversion before, and then that's 0.236 1/16. That is 1.48 10 to the minus 2 moles of oxygen. So now we came to a very important stage now. This is the mole ratio, and that's the mole ratio. And you need to find the closest integer that you can find out here. So the way to do is looking at the numbers, find out which number is the smallest, and this is the smallest, right? So what you need to do is now divide this one by 1.48. Divide by 1.48. Divide by 1.48. 10 to the minus 2. Okay? Multiply by 10 to the minus 2 for everything. So by doing so, the closest that you can find out is, this is more like now. Okay, having this is like 1 moles of carbon, because that's the smallest one, and then this one becomes double, right? This is almost 3, right? This is almost like a 1.5, okay, quote unquote. So this is a 2 moles of carbon, and the bottom one is 1 moles of oxygen, and then this one is 6 moles of hydrogen. And that's this is what we find out, right? So this is an X, Y, and Z number that we can use. So that's why carbon, hydrogen, and oxygen, X, Y, and Z. Now the empirical formula is C2H6O. That is a compound. And this is a compound that with the 2 carbons, and then I can easily imagine that carbon and carbon with hydrogens and oxygen. So this must be the compound, one of the example here. Right? So this is a organic compound that has a. So this is an empirical formula. This is a molecular structure. It is CH3, CH2OH. We call ethanol. Okay, ethyl. Alcohol, and that's a compound that we can find out from here. Okay, so this is a pretty much long problem the way that I solve, but I want to recap you once more. So the information that is given is this is an organic compound, and their mass is given. Organic mass is given, and then the products mass are given here. And the clue is the CO2 mass is related to carbon mass of organic compound, and water mass is mostly directly related to hydrogen mass from the organic compound. So then I establish my reaction equation, and then I'm trying to figure out the easiest one to find out, which is the mass ratio shown up here. Okay, so I'm trying to find the mass ratio, carbon mass, hydrogen mass, and oxygen mass based on the relationship that I can find out, and then easily convert that into the molar relationship, and then find out the closest integer. That's what I mean, X, Y, and Z ratio. And then here we find out that from this relationship, we find that even this one, if this 1.48 becomes a 1, divide the other numbers, and you'll find that this is close to 2, this is close to 1, this is close to 2, this is close to 6. And so that's why we come up with this data points to conclude that empirical formula looks like that. Thanks for listening.